Welcome to the 3LC Data Centric AI Hackathon. In this video series, I'll walk you through the entire challenge and show you how to build an image classifier that does chihuahuas from muffins using 3LC. But here's the twist. First, you get a very limited number of labeled training samples, and second, you are not allowed to change the model architecture or use any pre-trained weights. So how do we improve model performance? Instead of focusing on model-centric changes, we focus on improving the training data, and to do that, we use model feedback to guide us systematically in refining and expanding the dataset. This approach is called data-centric AI, and we'll implement it step by step using 3LC. Before we begin, I highly recommend that you review the Kaggle competition page if you haven't already. And in this specific video, I'll briefly explain the challenge, show you how to download the starter kit, and walk you through the full environment setup on your local machine so that you can participate smoothly throughout the competition. So the challenge is pretty simple. It's a binary image classification challenge, so you have to build a model that classifies each image as either a chihuahua or a muffin. On the Kaggle page, you'll find several important sections, such as overview, description, evaluation, dataset description, and all other sections which are important and will get you sufficiently informed about the competition. So I highly recommend going through them thoroughly. In traditional ML, most of the effort goes into improving the model, so bigger networks, different optimizer, more epochs. So here we're flipping that, and as Andrew Ng says, data-centric AI is the discipline of systematically engineering the data used to build AI system is exactly what we're going to replicate using this competition. So to start with, you have 100 labeled samples, 50 of each class, and a huge pool of unlabeled images. This is where the magic lies, and we are going to use these in the future to add little by little in our main dataset. So let's move on to the environment setup. So in order to do these, all you have to do is just follow these step by step, and then you should be set. First up, you need a 3LC account. You can go to this link and create one. Okay, so we are in. And this is very important because the API key here is what we require for the initial setup. Let's move on to the next step, which is the Python requirement. The Python requirement that you have is you need to have a Python version of 3.9 and above, but it should be under 3.14. And to check which Python version you have, all you need to do is run this in your command prompt. And as you can see, I have the Python 3.12, which is fine. Next step is pretty simple. Just go ahead, and if you are on a Windows, use these commands to create your virtual environment. On Linux, you can use these ones. Then we activate our environment. And next step is very important. If you have a GPU, I suggest that you follow these steps. And if you do not, you can follow these. You can follow the second option. Why this is important is because in order for you to use the Torch version with GPU support, you need to first install it. And also to check the CUDA version, you can run the following command. Oops. And then you'll have the CUDA version shown to you, and based on that you can download using the command given. As you can see, I already have it installed. This should probably take a couple of minutes, and then you can move on to the next step, is copying this command. I have a GPU, so I'm using this. If you use a CPU version, it's not going to make a lot of difference because the dataset is pretty small. So training should be considerably fast on the CPU as well. So as you can see, I already have the requirements satisfied, but in your case, you probably might require 5 to 10 minutes for this to install properly. If you have any concerns that you face, you can always head over to the documentation. In the FAQ section, you'll find a lot of questions, and if you do not find any of these here, you can always join our Discord using the link given here and ask questions there. Moving on, the next step, as I told you before, the API keys are important. So you'll need this command. All you need to do is paste it over here, and your API key will be verified and your workspace will be connected. This is just a one-time step, so you don't need to do this over and over again. Once you do it, you can just forget it and focus on the task at hand. Next step is running the 3LC object service. This object service is required for you to connect your dashboard so that it can talk to your data essentially. And let's wait for it to run. So every time you need to access the dashboard, you need to run this service. And once the service is up and running, you can open up the following URL and you will be on the dashboard. So this is what the home page of the dashboard should look like. You don't need to worry about a lot of things, but for starters, this is where you will be able to see our projects. And as I'm going to show you in the next step, once we download the starter kit and register our dataset, we'll be able to visualize it in this dashboard. So without any further ado, let's go ahead and download the dataset. To do that, you'll need to head over to the data tab, scroll all the way down and hit download all. This should take less than 10 seconds. And then all you need to do is extract the files. And once the extraction is done, you can open it in any IDE of your choice. So I have it in Cursor. That's fine. To give you some background, these are the files that you have. Let's go through them in a couple of minutes. The data folders which have the test, train, and val split, which is pre-split for you. You don't need to touch this. You need to worry about the other files. This is the config.yaml file. Here you can change the training configuration however you want depending on your system. So if you have a better system with a better GPU, you can increase the batch size. If you have a if you're running on CPU, for example, and if it's considerably slow, you can try reducing the batch size, reduce the epochs. You can do a lot of stuff here. But these three files are the most important ones. The register tables.py file, which you only need to run once, because what this will do is take your data, convert it into tables, and that is something you'll be able to see on the dashboard. And a table essentially is the main object that you'll work with, and it represents the collection of your data and lets you visualize and analyze it in the dashboard. So let's go ahead and create the environment and run this script so that we can see our data set in the dashboard. To do that, let's go back here. Okay, now this is done. We have activated. Okay, we are in the environment. All we need to do is we need to cd into the directory that we have downloaded the data folder into. Let's take a look at the files available. So we are in the correct directory, as you can see, and let's just go ahead and run python register tables.py. Now what this is going to do is that it has a predefined schema that will take your data set and it will register them as two tables, which are train table, which is one of them is a train table and one of them is a val table, which I'll show you shortly once it's created. And if you're curious about where it's located on the local system, you can find the URL over here. And this is important so that once you do a lot of training iterations in the future, you'll need to know which train table revision you are using to train your models on. So let's go to the dashboard. Our tables have been registered. And as you can see on the main page here, 30 seconds ago, this folder was created, which is our project. And two tables have been created over here. You don't need to worry about the filters right now. Just focus on the tables that have been created. You can see that tables are over here in this tab. And once we run our training scripts, we'll have runs over here in the future, which I'll tell you more about in the upcoming videos. So let's try to inspect the train run. Just double click on it and you should be in this view. On the left hand side, you can see the filters. These are the IDs that you can scroll through. You have a total of 3,732 IDs over here, out of which 50 are labeled as chihuahuas, as you can see, and 50 are labeled as muffins. And here is the huge set of undefined samples which you'll use in the future to add to this set of training samples that you have which are labeled. So to visualize these as a 2D chart, what you'll need to do is, first up, just go ahead, select the image column, control and select, hit control and select the label column as well. And once you right click on it, you can see two options, which is create 2D chart and create 3D chart. In our case, we need to create a 2D chart, and you can also use the hotkey number 2, which is on your keyboard, to create them. And you should have this simple 2D chart which is given here, which you can filter through, and you can just select your keyboard keys to iterate through each and every sample like so. These are 50 images, and if you want to take a look at the muffin images, let's take a look. These are the ones. Yeah, you can just use your keyboard keys and you should be fine. And one important column that I wanted to talk about is the weight column. This column is important during training. It is because, as you can see in the undefined samples, the weight is set to 0. So essentially during training, we are gonna add these samples to our training samples pool. And as you can see in this one, the labeled images have a weight of 1. So essentially what that means is that the model will see these samples equally while training. If you see in the future, if the model struggles on a few examples, you can try to increase the weight and experiment with them to increase performance, but that is towards the advanced stage and the final video that I'll show you. But for now, this is the end.